Hello and welcome back to another video. In this problem, we're asked if g of x is equal to x sixth plus x to the fourth, where x is greater than or equal to 0, use a computer algebra system to find an expression for the inverse of g. And then we're asked to use the expression in part A, both the one that's given and the one that we find with the inverse, to graph these two functions along with y equals x on the same screen. So I've plugged this into Wolfram Alpha. And what we can see is that given x to the sixth plus x to the fourth, we have this very long, very confusing, but applicable inverse. And it plots us right in Wolfram Alpha for us with the line y equals x. And we can see that they are reflecting over the line y equals x, right? They're mirror images of each other. And if we're dealing with x is greater than 0, then what we can do is we can zoom in and say, okay, our pink line here is the original function. So x is greater than 0 applies to this part right here and not this part. And it corresponds with the reflected version of itself, this blue part, where y is greater than 0 on the other function. So this part does not apply because x is less than 0, and this part does not apply because y is less than 0. And these are the parts that are eliminated by the domain restriction in the function. So if we were to only look at the first quadrant, in pink we have our original function, in blue we have our inverse function. We can see that they are mirror images of each other over the line y equals x. We can see that by doing this, using Wolfram Alpha, we are not only able to get the very complicated inverse instantly, but we are able to graph them perfectly and see the relationship between a function and its inverse. I should clarify, since we're only looking where x is greater than 0, and in that case where y is greater than 0, this plus or minus doesn't apply. We're only looking at the positive side, so you can just ignore it. Again, because of the original domain restriction.